Part 2, predictable dice. I'm sorry for the mess on my paper, but my first video didn't turn out, so I had to erase. Again, a good reason why we use pencil in math. So, just a review. When we follow the instructions for multiplying the top of one die times the top of another die, and we go through this 4 times following these instructions for the products, and then we sum the products, our answer is always going to be 59. So we're going to see why that works. And what we're going to do, instead of using the actual numbers, is we're going to use the variables that are in the chart that we created. So the first instruction is to take the top of die 1 times the top of die 2. So when we look back at our chart, we can see that regardless of which number is rolled here and which number is rolled here, let's say it was a 4 and a 3, the top of the white die or die 1 is going to be X, and the bottom is going to be 3. And we can choose any two that have a sum of 7. Remember, we're only looking at the top now. 1 and 6, 2 and 5, 3 and 4, 3 and 3, and so on. So that means we're always going to be multiplying X times Y. So down here, I'm going to write my first step, and that was X times Y, and that's going to equal XY. This is my product in algebraic terms. My second step was to take the bottom of die 1 and the bottom of die 2. So again, we'll just say that we're working with 3 and 4 here. And we'll say over here it was 1 and 6, just so we can kind of focus in on some things. So bottom of die 1 times the bottom of die 2. So here's my bottom. My bottom is 7 minus X times the quantity, 7 minus Y. Okay, so you know Mrs. Porras, she always likes to change her subtractions into additions. If you don't do that, that's fine. But this is the way I roll. So now I have 7 plus a negative X times 7 plus a negative Y. So what I need to do is I need to distribute both of these quantities within this set of parentheses over to this set of parentheses. So I'm going to start with my 7 right here, and I'm going to distribute it first. 7 times 7 is 49. Plus, now I'm going to distribute my 7 over to my negative Y. So that would end up being negative 7Y. So I've distributed my 7 to all of the terms in this expression. So now I'm going to come and work with this negative X, and I'm going to distribute it through the second one, and negative X times 7 is negative 7X plus, now here I have a negative times a negative. So a negative times a negative is a positive. So that's going to be XY. The other reason I like to change these subtractions to additions is because when I do distributions like this, I never have to worry about what my sign is in between my terms. I just always know I'm adding. So that just, for me, that is helpful. Okay. So we took the bottom times the bottom and the top times the top. Now we're going to take the top times the bottom. Top of the first one times the bottom of the second one. So the top of the first one is x times the bottom of the second one, which is negative or 7 minus y. So again, change that before I start. And I'm going to distribute that x. So I have 7x. And I have negative xy. And again, I could call this negative yx. It's kind of customary in algebra to go the order of the alphabet. But because multiplication is commutative, meaning it doesn't matter which way you do it, actually either order would be fine. I would just stay consistent because I had my xy there, use my xy there. All right, and the last one I'm going to be doing is the bottom of the first die, the white die, times the top of die number 2. So this time it's the bottom, 7 minus x, times the top, which is y. And you can put the y in back of the parentheses. Here's my top. You can put the y in back of the parentheses or in front of the parentheses. Typically you see it in front, but just for purposes of demonstration, I'll just go ahead and leave it in the back. And again, this is a plus a negative x now. So I'm just going to distribute that, and I'm going to get 7y, and y times a negative x is going to be negative xy. Now, the last thing we do is we add up all of the products. So we're going to take all of these and we're going to combine them. So I have xy, and I like to put little check marks once I've taken care of it, because if I get interrupted and I come back, I know where I left off. Sometimes that happens to me. Okay, so now what I want to do is combine like terms. And you can probably see that we have a lot of opposite terms that could sum to 0. So for example, I have a positive xy here and a negative xy there. When I combine those, they're going to equal 0. So I'm going to put little circles around them, indicating that those sum to 0. I don't want to start drawing lines to them because that gets complicated. I don't have any other constants. I have a negative 7y here, and I have a positive 7y here. So I'm going to circle those. Those sum to 0. I have a negative 7x and a positive 7x. I have a positive xy, I have a negative xy. So I have, the only thing that I have left is 49. That is why this works algebraically. So what I want you to do now is apply this understanding. It's easy to copy down something when somebody is explaining it to you from a video. But now what I want you to do is to think about a different kind of die. And would that same process hold for a different kind of die? So we're going to look at what would the answer be? What would your prediction be if you had a dodecahedron or a 12-sided die? Hedron means face, deca means 10, do means 2. Like a duo is 2 people. So do means 2. That's where you get the 12. Now, some dodecahedrons will not have this same structure because the numbers that they choose to put on the opposite sides may not be what this is going to be, but we are going to have the sum of the top and bottom be 13. So if the top number was 1, the bottom number would be 12, because 12 plus 1 is 13. This would be 11, 10, 9, 8, 7. And the reason I'm stopping there is because then we're going to be repeating the same thing again. If the top number was 7, the bottom number would be 6. So they're just the opposite then. We're going to assign this is incorrect. We need the other die. I just looked at that and realized I did that wrong. We need the other die. This represents one die, what the top and the bottom would be. We need the other die to be the y's. So we would have a similar chart. And I maybe should have just made these totally vertical, but I didn't. So this is going to be our y values, our other dodecahedron. So if we had a 1, we would have 12. If we had a 2, we would have 11. If we had a 3, we would have 10. And the same would be true on the other die. The sum would be the same. These are just still going to represent the second dodecahedron. So again, if I had a white one and a green one. And I want you to determine 2 things. Determine what the sum of the products would be. And I also want you to demonstrate algebraically why it works. So in other words, I want to see this, why it works algebraically. Okay, good luck.